Right, this one's all about vertical asymptotes. So the function g is continuous at all x except for 4. And then as we approach 4, our limit goes to infinity. If you go to the videos about infinite asymptotes, this is literally the definition of having a vertical asymptote. So the answer is C. The only answer between C and D is x equals 4 or y equals 4. X equals 4 goes in this direction. Y equals 4 goes in this direction. Well, it's vertical, so we want it going up and down. So that's why C is the right answer. 18 could have been a question I gave you on our Unit 1 test. Our function values are getting large. Well, x is getting close to 1. Well, if x is getting close to 1, that means you want x going towards 1. And then our function values are going to be equal to infinity. So C is the right answer here. X is getting close to 1. Our function values are getting very large. All right, for question 19, if you try to plug in 2, you can't because you'd be dividing by 0. So the next thing you would try to do is simplify, but nothing simplifies, which means we're going to have an asymptote. So automatically, I know I have to get positive or negative infinity. And how can I decide? Well, if I were to plug in 2, or a number close to 2, 3 times 2 is 6. Important thing, that's a positive number. On the bottom, I'm squaring whatever I get. And whenever you square anything, you also get a positive number. So the top's positive and the bottom's positive. My answer has to be positive infinity, B. All right, this one is really similar to the last one. I try to plug in 3 from the start. I can't. I get an answer that doesn't make sense. I divide by 0. So let's see. I should rewrite this first. And I can factor the top as x minus 4 times x plus 2. I can factor the bottom as x minus 3 times x plus 1. And nothing cancels out. So I know I'm going to get an asymptote. So it automatically tells me my answer is going to be positive infinity or negative infinity. I have to decide which one is it going to be. And the way I do this is I'm looking at 3 from the right-hand side. So these are numbers that are just bigger than 3. And let's say it's 3.1. That's a number just bigger than 3. All right, so for each of these ones, I think about what's going to happen when I plug in 3.1 into all these different pieces. And again, just like the one before this, all that really matters is whether they're positive or negative. 3.1 minus 4, that's going to be a negative number. 3.1 plus 2, that's going to be a positive number. 3.1 minus 3, that's still going to be positive. And 3.1 plus 3, that's also positive. And that should be a 1, not a 3, because I'm adding 1. At 3.1 plus 1, doesn't matter, it's still positive. So if I have all these different numbers, if I have 1 negative and 3 positives, that final answer is negative. So my final answer is just negative infinity. I know it's going to infinity, or one of the infinities. And because I have 1 negative and 3 positives, my answer has to end up being negative. All right, in this question, we're talking about horizontal asymptotes, which is when x is going to infinity. All right, so for the first one, horizontal asymptote, the trick with rationals is you look at the biggest power of x. So we're looking here. And a lot of people knew to do that correctly, but they just missed this negative sign. So it's negative 2 on the top and 3 on the bottom gives me a. All right, and that's happening because I only look at the highest powers of x. But then those are going to cancel out, and that gives me just the negative 2/3. All right, for 22, all right, we have this polynomial on the top and exponentials on the bottom. We had an example like this on one of our worksheets. Basically, exponentials get really, really big compared to our polynomials. So just like whenever the bottom power is bigger, this is going to go to 0 because the bottom's getting bigger. The same thing's going to happen here. Exponentials are way bigger than polynomials, so I'm just going to get 0 because the bottom's bigger. All right, and that actually means I don't have to say much for 23 because our biggest power here is x squared. Our biggest power here is x to the 4th. X to the 4th is bigger, so I just get 0. And the last one, again, a limit at infinity is the same as finding a horizontal asymptote, so I look at the highest powers. It's there and there. So this is the same as if the other stuff wasn't there because we only care about the highest powers. But then those things are going to cancel. The powers of x are going to cancel. And I just get 3. Right, so not much work to show, you just have to know what you're doing, looking at the highest powers of x and canceling out. All right, so you can see this page, there's not a lot of work to do when you know what you're doing. There's the horizontal asymptotes, or where you're looking at those highest powers of x, right, when they're the same, like 21 and 24. They kind of just cancel out, and you get those coefficients as your answer. Right, when the bottom is bigger, you'll get 0. Also, if the bottom's exponential compared to a polynomial, you get 0. The only one that's not covered on here is if the top was bigger, like this. That just goes to infinity, and there's no horizontal asymptote. And the last slide, the intermediate value theorem. Actually, let's start with the bottom one for this one, because what is the intermediate value theorem? It says if your function is continuous, on some interval, a to b, then if there's some value, I think in the original one from the slides, I think I called it z. All right, so my function is continuous, and there's some number that's in between my outputs, in between my y values at the start of the interval, at the end of the interval. Then the intermediate value theorem says, then if there is a c such that f of c equals z. All right, so this is what the intermediate value theorem says. The most important thing being, if your function is continuous and there's some y value in between the y values that you get, then you have to hit it at some point. So there has to be this c that would give me z out. All right, so that's the intermediate value theorem. That's kind of the least amount you could write to get the full credit on that. So continuous, you have something in between your outputs, and there is something that would give you that value. All right, so knowing that, we can answer these questions. All right, this one's saying it's continuous from 0 to 7. And what would it take for us to know that at some point it's 50? Well, at 0, you're going to get 24. At 7, you get 68, and 50's in between those two things. And the only thing I need to know is the assumption for the intermediate value theorem, and that's that it's continuous. Being defined is not good enough, because if I had 20 down here and 68 up here, and then 50 would be in the middle. Just being defined is not good enough, because this function is defined everywhere. All right, but it jumps. I could jump over that line. Being increasing is not good enough, because I could increase and then jump over the line and still be increasing. All right, but the thing that makes sure that I don't lift up my pencil is that it's continuous. And if it's continuous at some point, I have to go through that line to hit 50. All right, so the only thing that matters is that it's continuous. All right, the intermediate value theorem gets used a lot for finding zeros, because 0 is here, and all the negatives are down below, and all the positives are above. So every single time I go from negative to positive, I have to cross 0 every time I go from positive to negative. So here, negative to positive, that has to be a 0 in there. All right, positive to negative, there's a 0 in there. Negative to positive 0. So my answer is 3. There has to be at least 3 zeros for this continuous function by the intermediate value theorem. All right, this one, if we're going to use the intermediate value theorem from 5 to 6, which one of these equations has to happen? When I plug in 5, 25 minus 25 plus 1 is 1. When I plug in 6, 36 minus 30 plus 1, which is 7. All right, so I start at 1 and I end at 7, which means I have to hit every number between 1 and 7, and only one of these numbers is between 1 and 7, which is 3. All right, so that's how you do these problems. All right, so this is a review of all the problems from the Unit 2 test. Again, as I mentioned, all of the problems on the retake are pretty much the same problems with different numbers or changing a couple of things. So the things you're checking for and the things you're doing for each problem are going to be the same. The answers are just going to vary depending on how I change the problem.